Hello everybody, I'm here today to talk to financial mathematics students on the BSc programme who are about to or looking to come to Kent. So today, my name's Sean Parsley. I'm a lecturer in financial mathematics and actuarial science. I lecture all stages of students, so right from first years all the way to postgrads. BSc financial mathematics students in their first year will see me. They'll see me in the autumn term, and that's under the guise of MA 345 Introduction to Finance. So MA 345 is predominantly a financial mathematics module. There are some other small elements to it which you need to help with your studies further along at Kent. But most of it's around learning the skills to be able to conduct financial mathematics well. As you can see from the bottom bullet point there, it investigates how the value of money changes over time. So we all understand the concept that, £1 today won't most probably be worth the same as £1 in 10 years' time, due to a number of reasons. Inflation is something which we'll look at, and we all know well. And we also know that, if you deposit money now, you expect to earn a return on that money, earn interest on that money. And if you borrow money, you expect to pay whoever you're borrowing from some interest too, some borrowing rates of interest. So these are all things which you'll learn during the MA 345 module. Now, what do we want to talk about today? Well, mathematics is obviously key for you to learn financial maths well. And I wanted to talk to you about, some maths which you would have learned whilst at school, especially on your A-level course, which it's really useful to be hot on, to be really good on, and and to be able to manipulate that level of mathematics to apply that to financial maths. So one area is exponential functions. So that word exponential you should have heard of many times. You should have seen it quite a lot through your A-levels, and even in some of the other some of the other subjects such as physics and things like that. So there's an example of an exponential function, probably the most basic form of it. And you should recognise exactly what's going on there. Now, why am I talking about exponential functions when we were previously talking about money and financial mathematics? There's two reasons really. Exponentials can be used to describe compound interest well. So compound interest, as you can see, has got that word interest in, so that whole concept of money and paying interest or receiving interest. And then it's got this word compounding. Now, I'm not going to go into compound interest today. That's what MA 345 talks about. But I'm going to show you a graph of compound interest. That's the blue line. And you can see that, that's the shape of an exponential graph. Obviously, we've all seen lots of exponential graphs recently with COVID-19, with the infection rate, etc., etc. But in this instance, we are focused on compound interest, and you can see that compound interest can be described well by exponential functions. So that's one reason we use them. Now, another reason is they really help us when we're working in continuous time. That's more of an involved point, but really what that means is that helps us deal with continuous cash flows, which we're going to go on to in a second, and also then that helps us with dealing with things such as integration, which we use integration to to sum up series of cash flows through time, again, which we're now going to go on to. So as I say, we'll go on to an example. And here it is. Let's set the example up. So first of all, we receive a continuous cash flow between 0 and 4 of gt equals exponential to the power of 0.2t. So that's money we're getting in. That's a cash flow in. So the important thing here is don't worry too much about that shape of that cash flow. That's what MA345 is for. The key thing for you here is you can see that we're using exponential functions, which you've probably seen before. Next, what do we want to do? Well, we're probably gonna accumulate this cash flow. So let's define a interest function or a compound interest function ft, which is equal to e to the power of 0.03t. Now the question, what is the accumulated value of this at time 4? Right, okay, now, so you're going to see some maths which you'll sort of recognise, but for reasons unknown to you. So there we go. So you can see there's an integral between 0 and 4 of gt ft dt. So MA345 teach you why we use that integral. Here though, I want to show you how you can use mathematics which you have learned to solve problems. The real skill will be understanding when to use these integrals, and that's what I will teach you. So we substitute in ft and gt, as you can see, and from our knowledge of exponentials, we can combine the two exponential functions and form an exponential function of e to the power of 0.23t. You'll then remember that these types of integrals are what you typically done at A level. So hopefully you can solve that, or if you can't remember, do bring yourself back up to speed. And there we go. We integrate that, and you can see that the initial integral then is integrated to give 1 over 0.23, and then we solve between 4 and 0, i.e. the square brackets, and then the solution comes out at 6.56, 6.6, something like that. So this is really powerful. From nothing more than A-level maths, or a slight jump from A-level maths in terms of exponential functions, you can solve quite complicated problems which are really useful in the world of finance, and really useful outside of that as well in other areas. So suddenly you're starting to learn some really important tools which you should be able to get to grips with very, very easily, working with lecturers like myself. And then at the bottom I've said that we often use something called the by parts method for integration too. Again, I put that in because you would have seen it in A-levels. So try to remind yourself what that means. Where would we use it here? Well, if you remember the integral here of gt multiplied by ft, we would then we would have probably one of the two functions would just be a linear function. It would be something like gt equals 4t. So you can see then we haven't got the two exponentials to add together. So what do we do instead? Well, we then use by parts to solve that. So there's other examples we could go into, but for the sake of time, for here and now, I just wanted to show you how the things you learn, you're going to use, and are really important that you remember them. So in summary, as I said, you'll use the skills you've gained at school in a range of different mathematical situations. I've talked to you about financial maths, but you'll learn all kinds of situations. And then the point about exponentials, they're really important. So be really good at manipulating them, transforming them, integrating them, all these things. And of course, you can always come to me to help. And then the final point, that's exactly what I'm here to do. We're here to support you and guide you through your studies, but importantly at this time, especially with everything what's gone on with COVID-19, we're here to help you with your transition from school to university. So that's it. I hope that helps. Any questions, you can always email me. You'll see that on the blog, or anybody in the office. Everybody's fantastic. So thank you very much.